We're asked to give the symbols and the names of the elements that correspond to these electron configurations. So this one's full, that one's full, that one's full. Let's go to 3s, and it's going to be the first element in that section. All right, here's your 2s, right? Okay, so s's are right here. This block is your s block. Right. 1s is here, 2s is this section, 3s is this section, so it's going to be sodium. It's the first element in the 3s section. Sodium. All right, let's go to B. A we did in red. All right, now that one's full, that one's full. This one is going to be 2p3. Why wouldn't it be full, right? So 2p3. Here's your 2p section here. It's going to be 1, 2, 3. It's nitrogen. Nitrogen. Let me get rid of this. I'm going to keep writing on that periodic table. So, nitrogen. All right, let's go to letter C. That was full, 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 full. All right, 3p2. All right, of course you can just count these electrons. So let me tell you, if we give you something like this on your test, we're going to like block this out and give you just the last 2 or 3 orbitals. Okay, so that way you can't just count. All right, 2p2. Oh wait, 3p2, sorry. All right, here's your 2p block, or the section right there. 3p right there. All right, aluminum's 3p1, silicon is 3p2. All right, keep going. We're just going to count this. That's 8 electrons. That's going to be oxygen. We would give you something with many more electrons than just 8. That way we can block out the first, like this. All right, now go ahead. Now you can't count. You wouldn't be able to do it. All right, so the S's are full, the P's are full. All right, we're just going to go to 4s1. All right, so here's your 1s, here's your 2s, here's your 3s, here's your 4s, and it's the first one. There's potassium. All right, F. Let's block out some of this stuff. Make sure what I block out is full. Okay, be careful here. This one's not full, so you can't just go to 4s2. Because here, let me explain this. So a lot of times when they write this format of electron configuration, they'll group them by the principal quantum number. The 2's are together, the 3's are together, and so on. Now when you do that, that messes up the order of the Aufbau filling. In other words, it doesn't go by the order of the periodic table. All right, so you can't just go to the last orbital and say that's going to be the answer, because they've reshuffled it after it was filled, if that makes sense. All right, so you're going to have to, like, even if we block this out, you should know, right, that the 3Ds come after 4s because that's the order of the periodic table. All right, so if we go to here, let's say you go to 3D first. Here, I'll show you this way. So this is your 3D right here. And some of you are like, you're just making stuff up. No, I'm not. All right, so I showed you in my last video, it's like your n equals 1. All right, only has your s. N equals 2, your second energy, you have your s's, and then you have your p's. You have 3 of them, 3 p's. N equals 3, that's the first time you have the new orbital available as your d. So that's why I'm saying this is the first d section. There's 10 of them, 10 columns representing the 10 electrons that go into the d orbitals. All right, so kind of getting off track here. 3d2 represents titanium, but that's not the answer. Okay, because 4s wouldn't be on this side, so you know that's the filling is out of order. That's what I was trying to show you in a very roundabout way. All right, so 4s2, we're done there, and this is going to be titanium. Actually, that's the answer. titanium. All right, so this, if you were to make this electron configure, you would probably write that last because you would have filled it last. All right, but some teachers or books will make you reshuffle it, right, which is kind of pointless to me. It's just stupid because there's enough things that go on in chemistry. It just seems pointless, and that's just one of them. All right, maybe there's a good reason. You can share it with me.